In this question, it is given that let x equal to 2 be a local minima of the function fx equal to 2x to the power 4 minus 18x square plus 8x plus 12, where x belongs to the interval minus 4 to 4. If capital M is the local maximum value of the function f in this interval, then M is equal to. You have to find the correct choice. Before I do this question, I would like you to remember this concept that in case of y equal to ax cube plus bx square plus cx plus d, here I am supposing that a is positive, or in the graph of y equal to ax power 5 plus bx power 4 plus cx cube plus dx square plus ex plus f, or the graph of here and so on. In all the cases, I have supposed a is positive. That is, I mean to say, for any odd degree equation in x having coefficient of maximum power of x, that is a, is positive. Note that I am saying the equation should be odd degree and the coefficient of maximum power of x is positive in all these cases. The graph is sure to be of the type coming from below and finally going up. It may be this also. It may be this also. It may be this also. That is, main thing is for every odd degree equation in which coefficient of maximum power of x, that is a, is positive, graph always come from minus infinity and go to infinity. This is valid for every odd degree equation in which coefficient of maximum power of x is positive. And where the graph will turn and how many times graph will turn, that depends upon degree and the value of coefficients. But the main thing will be always that the graph will come from minus infinity and will go in infinity. And remember this concept also, that for every continuous function, maxima and minima always come alternately. After maxima, maxima can never come. That is a graph maybe of this type also. It is maxima. This is a point of inflection and this is a point of local minima. That is, I mean to say, after maxima, either point of inflection comes or directly minima comes. After maxima, directly the maxima can never come. This is valid for every continuous function. And in case if a is negative, then it is sure that the graph will come from infinity and will go in minus infinity. That is a graph maybe of this type. The graph may be of this type. Or the graph may be of this type. Where the graph will turn and how many times the graph will turn, that depends upon the degree and the value of coefficients. But the main thing will be always of this type. The graph will come from infinity and will go in minus infinity. And I'm going to use these concepts in the solution to this question. To find the point of local maxima, given fx equal to 2x bar 4 minus 18x square plus 8x plus 12. I find f dash x. I will be getting 8x cube minus 36x plus 8. And because it is given that x equal to 2 is the point of local minima of this function, it means one root of this equation is sure to be x equal to 2. That is, one factor will be x minus 2. And to find the remaining part, one way will be divide this equation by x minus 2 and the quotient will be written here. Agreed, that is not wrong, but try to do it by using common sense. If it is x here, it is sure that we'll have to write 8x square, because 8x cube can come only if it is 8x square written, and that multiplied by x will give you 8x cube. Because it is minus 2, minus 4 will be written to get 8. Only you have to find the linear part. Say it is lambda x, and it is not difficult to calculate the value of lambda. Compare the coefficient of x square, but comparing coefficient of x square is slightly better, because on left hand side coefficient of x square is 0. This will be equal to x square will come when this is multiplied by this or when this is multiplied by this. That is lambda minus 16. That is the value of lambda becomes 16. Had I compared the coefficient of x, then also I would have got the same answer. You can see very easily. Coefficient of x on left hand side is minus 36, and coefficient of x on right hand side will be, x will come when this will be multiplied by this or when this will be multiplied by this. That is minus 2 lambda. Minus 4 is the coefficient of x. From here also, if I try to find the value of lambda, I'll be getting lambda as 16. Hence, this equation becomes x minus 2 into 8x square plus 16x minus 4 equal 0. And if I put this equal 0, I get 2x square plus 4x minus 1 equal 0. That is, the value of x is minus 4 plus minus under root 16 plus 8 by 4. That is x equal to minus 2 plus minus under root 6 by 2. That is, the two roots are minus 2 plus root 6 by 2, and the second root is minus 2 minus root 6 by 2. Hence, I can say the graph of this function will have turning point at x equal to 2, at x equal to minus 2 plus root 6 by 2 and minus 2 minus root 6 by 2. Hence, I can say the graph of this function will have turning point at x equal to 2, at x equal to minus 2 plus root 6 by 2 and minus 2 minus root 6 by 2. And initially I forgot to tell you how to draw the graph of even degree equation. Now I'm telling you, and after that I'll be using that concept in the remaining part of this question. Say you have to draw the graph of ax square plus bx plus c, or you have to draw the graph of ax bar 4 plus bx cube plus cx square plus dx plus e, or the graph of ax bar 6 and so on. If a is positive, remember that the graph will be always coming from up and finally it will go up only. Where the graph will turn and how many times the graph will turn, that depends upon the value of the coefficients. But the main thing in all these graphs will be the graph will come from up and finally it will go up provided A is positive. The graph may be this, the graph may be this, the graph may be this. That is, in all these cases, the main thing is it is coming from infinity and it is finally going in infinity. It is valid for every even degree equation where A is positive. And similarly, if A is negative, either the graph will be this, that is coming from minus infinity and going in minus infinity if A is negative, or the graph may be this, or the graph may be, that is the main thing will be this, that the graph will be coming from minus infinity and finally going in minus infinity. This is valid for every even degree equation where coefficient of maximum power of x is negative. Where the graph will turn and how many times the graph will turn, that depends upon the coefficient. Hence we can say the given graph has three turning points: -2, minus root 6 by 2. Second will be at -2 plus root 6 by 2, and third will be x equal to 2 is given. It is clear that this is greatest and this is smallest. And we know that for every even degree equation, when it is coming from up, first time when it will turn, it will be surely giving local minima. Second time it will turn, that will be giving surely maxima. And third time when it will turn, that will again surely give local minima. And from these three numbers, it is clear that because this is the smallest one, this point will have x coordinate -2 minus root 6 by 2. This point will have x coordinate -2 plus root 6 by 2, and this point will have x coordinate 2. And because it is given that capital M is the local maximum value of this function, then according to the theory which I told you just now, local maxima will occur at -2 plus root 6 by 2. That is, I can say capital M is f of -2 plus root 6 by 2. And now the next difficulty arises is if I have to find the value of f -2 plus root 6 by 2, then I will have to put this value of x in this hole, but putting this value of x in this and calculating is a lengthy procedure. Then how to proceed? See, let x equal to -2 plus root 6 by 2. Take 2 on this side and finally bring -2 on this side. That is, I will be getting 2x plus 2 equal to root 6. What I am going to do, you will understand after few steps. Now squaring both sides, I get 4x square plus 4 plus 8x equal to 6. That is, I will be getting 4x square plus 8x minus 2 equal to 0. That is 2x square plus 4x minus 1 equal to 0. And the equation I have got now, this means for this value of x, the value of 2x square plus 4x minus 1 will be 0. And what is the benefit of getting this? See, Now I say divide 2x power 4 minus 18x square plus 8x plus 12 by 2x square plus 4x minus 1. In the last step, you will understand the reason of all these steps. You can divide by normal way, or there is a shortcut way of dividing any polynomial by any polynomial, and by that method you can get the quotient and remainder just in one line. But to make you understand that way, that is not a part of this question. For that you will have to see my video I have separately made, in which I have explained how to divide any polynomial by any polynomial by shortcut way, and that shortcut way gives the answer just in one line. And when you will divide this by this, in quotient you will be getting x square minus 2x minus 9 by 2, and the remainder is going to be 24x plus 15 by 2. And because we know that dividend is equal to divisor into quotient plus remainder, hence I can say this is equal to 2x square minus 4x plus 1 into x square minus 2x minus 9 by 2 plus 24x plus 15 by 2. And now I tell you the reason of dividing this by this, getting quotient and remainder. The benefit is because actually I have to find the value of f of minus 2 plus root 6 by 2, and it was very difficult to put this value of x here and calculate it. I made an equation with the help of this, and because this equation had been obtained from here, it means one root of this equation is minus 2 plus root 6 by 2. That is, I can say for x equal to minus 2 plus root 6 by 2, this part will become 0. And because this is equal to this into this plus this, and because actually I had to put this value of x here, and putting the value of x here or here is same thing because both are equal. And here if I put the value of x as minus 2 plus root 6 by 2, this whole thing will become 0. 0 into anything is 0. Therefore, to find the value of this, I will have to put the value of x only here. That is, I will be getting 24 into minus 2 plus root 6 by 2 plus 15 by 2. That is, I get 12 into minus 2 plus root 6 plus 15 by 2, that is minus 24 plus 15 by 2 plus 12 root 6, that is minus 33 by 2 plus 12 root 6. Hence I can say first choice is the correct choice. Note that this procedure which I have used to find the value of this for this value of x is a standard way you must have studied in lower classes, but if you have not studied, remember this way. The similar thing you must have studied in the chapter of complex number also. For example, if I say find the value of this for x equal to 2 minus 5i, obviously putting the value of x as 2 minus 5i in this whole is very lengthy. The similar way is there for getting the value of this for x equal to 2 minus 5i or 2 plus 5i. That is anything which by putting gives you lengthy calculation.